This right here is the graph of y is equal to x to the third over 6 plus 1 over 2x. And what I want to do in this video is figure out the arc length along this curve between x equals 1 and x equals 2. And so we've already highlighted that in this purplish color. So I encourage you to pause this video and try it out on your own. And I'll give you one hint. Assuming that you apply the arc length formula correctly, it'll just be a little bit of power algebra that you'll have to do to actually find the arc length. So I'm assuming you've had a go at it. Let's work through it together. So a few videos ago, we got a justification for the formula of arc length. We got arc length is equal to the integral from the lower boundary in x to the upper boundary in x. And this is the arc length. If we're dealing in terms of x, we could actually deal in terms of other variables. And so it's going to be 1 plus f prime of x squared dx. So for this particular f of x, we just need to figure out what f prime of x is. We need to square it. We need to add 1 to it. And then we have to take the square root of that. So let's do all of that step by step. So what is f prime of x going to be? Let's see. X to the third derivative of that is 3x squared. So 3x squared, 3 over 6. So it's going to be x squared over 2. And then this is 1/2 x to the negative 1 is one way to think about it. And so that's going to be negative 1/2 x to the negative 2. Negative 1/2 x to the negative 2 power. Now, what is f prime of x squared? So it's going to be, actually, let's just write out, what is 1 plus f prime of x squared? So it's going to be, 1 plus f prime of x squared is going to be equal to, it's going to be 1 plus this thing squared. And so let's see, this term right here squared is going to be x to the 4th over 4. So it's going to be x to the 4th over 4. Now the product of these times 2 is going to get us negative, let's see, x squared times x to the negative 2 is just going to be 1. And so it's just going to be negative 1/2, right? I just took the product of these two and then multiplied that by 2. Yep, it's going to just be negative 1/2. And then this term right over here squared is going to be positive 1/4 x to the negative 4. 1/4 x to the negative 4. And let's see, we have a 1 and a minus 1/2, so we can simplify that a little bit. This is going to be equal to x to the 4th over 4. 1 minus 1/2 is plus 1/2. Plus 1/4 x to the negative 4 power. Let me make that a little bit clearer. X to the negative 4 power. So this seems a little bit strange, and we're going to have to take a square root of it. But maybe we can set this up so that it's a product of perfect squares, because it does look, x to the 4th. And let's see if we can write this in a way that we would recognize how to factor it a little bit better. So let's factor out a 1/4 x to the negative 4th power. So this is going to be equal to 1/4 x to the negative 4 times, so let's see, I factored that out. So if you factor 1/4 x to the negative 4th out of this first term, and I could color code them a little bit, this first term, when you factor this out, is going to be x to the 8th power. Now, this term right over here, if I factored out a 1/4, it's going to be equal to 2x to the 4th. So this term right over here, once again, this is the powering through the algebra part. So plus 2x to the 4th. And then this one is pretty straightforward. This is just going to be equal to 1. So plus 1 plus 1. And now this is looking interesting, because this one, well, this right over here, we could rewrite as 1/2 x to the negative 2 squared. This is equal to, that same color, 1/2 x to the negative 2 squared. And then this over here, we could rewrite this as x to the 4th plus, actually let me write it this way, this is going to be x to the fourth plus 1 squared, right? X to the fourth times x to the fourth is x to the eighth. 1 squared is 1. The product of them times 2 is 2x to the fourth. So this over here is the same thing as that. And so now if we wanted to take the square root of both sides, so if we wanted to say the square root of 1 plus f prime of x squared, notice I'm just focusing on the algebra. So what we've done so far, this is 1 plus f prime of x squared. Now we want to take the square root of that. So that's going to be the square root of this. And so that's going to be equal to, square root of this is, let me just color code it. This is going to be 1/2 x to the negative 2 power times x to the fourth plus 1 times x to the fourth plus 1, x to the fourth plus 1. I did that right? Yep. Or I could actually, now that I did all of this to put this in a form that I could actually recognize, now I can distribute things back. This is going to be equal to, 1/2 x to the negative 2 times x to the fourth is x squared. 1/2 x squared plus 1/2 x to the negative 2. And if we're going to take the, let me rewrite this. So that's 1 plus f prime of x squared. But now let's take the definite integral. So let me give myself some space to write my dx. So we're going to take the definite integral, in this case, from x equals 1 to x equals 2. So it's the definite integral from x equals 1 to x equals 2 of this dx. So it's going to be the definite integral of this from x equals 1 to x equals 2 dx. And so this is fairly straightforward. The antiderivative of 1/2 x squared, that's going to be what? That's going to be 1. See, it's x to the third, and we divide by 3. So 1/2 divided by 3 is 1/6. 1/6 x to the third. And then this is going to be, we're going to increment, this is going to be x to the negative 1. We're going to divide by that. So minus 1/2 x to the negative 1 power. Is that right? Did I do that? Yep, negative 1. When you take it, yep, negative 2. And then this one, yep, that looks good. And we're in the home stretch. We're going to evaluate it at 2 and at 1. And so we get, when you evaluate it at 2, you get 2 to the third, which is 8 over 6 minus 1/2 times 1/2. So this is minus 1/4. And when you evaluate it at 1, you're going to have minus. So we're going to subtract, evaluating it at 1. It's going to be 1/6 minus 1/2. And now we just have to evaluate these fractions. So this is going to be, let's see, this is, if we divide, this is 4/3. 4/3 minus 1/4 minus 1/6. And then we have plus 1/2. And let's see, the common denominator here would be 12. So this is be 4/3 over 12 is 16 over 12, right? Multiply the numerator and denominator by 4. Minus 1/4 is the same thing as 3 over 12. Now this is minus 2 over 12. And then we have plus 6 over 12. And so this is going to be equal to, I think we deserve a little, at least a little mini drum roll right over here. So 16 minus 3 is going to be 13, minus 2 is 11, plus 6 is 17. So there we have it. The length of that arc along this curve between x equals 1 and x equals 2, that length right over there is 17 twelfths. And we're done. This right here is the graph of y is equal to x to the third over 6 plus 1 over 2x. And what I want to do in this video is figure out the arc length along this curve between x equals 1 and x equals 2. And so we've already highlighted that in this purplish color. So I encourage you to pause this video and try it out on your own. And I'll give you one hint. Assuming that you apply the arc length formula correctly, it'll just be a little bit of power algebra that you'll have to do to actually find the arc length. So I'm assuming you've had a go at it. Let's work through it together. So a few videos ago, we got a justification for the formula of arc length. We got arc length arc length is equal to the integral from the lower boundary in x to the upper boundary in x. And this is the arc length. If we're dealing in terms of x, we could actually deal in terms of other variables. And so it's going to be 1 plus f prime of x squared dx. So for this particular f of x, we just need to figure out what f prime of x is. We need to square it. We need to add 1 to it. And then we have to take the square root of that. So let's do all of that step by step. So what is f prime of x going to be? Let's see. X to the third derivative of that is 3x squared. So 3x squared, 3 over 6. So it's going to be x squared over 2. And then this is 1/2 x to the negative 1 is one way to think about it. And so that's going to be negative 1/2 x to the negative 2. Negative 1/2 x to the negative 2 power. Now, what is f prime of x squared? So it's going to be, actually, let's just write out, what is 1 plus f prime of x squared? So it's going to be, 1 plus f prime of x squared is going to be equal to, it's going to be 1 plus this thing squared. And so let's see, this term right here squared is going to be x to the 4th over 4. So it's going to be x to the 4th over 4. Now the product of these times 2 is going to get us negative, see, x squared times x to the negative 2 is just going to be 1. And so it's just going to be negative 1/2, right? I just took the product of these two and then multiplied that by 2. Yep, it's going to just be negative 1/2. And then this term right over here squared is going to be positive 1/4 x to the negative 4. 1/4 x to the negative 4. And let's see, we have a 1 and a minus 1/2, so we can simplify that a little bit. This is going to be equal to x to the 4th over 4. 1 minus 1/2 is plus 1/2, plus 1/4 x to the negative 4 power. Let me make that a little bit clearer. X to the negative 4 power. So this seems a little bit strange, and we're going to have to take a square root of it. But maybe we can set this up so that it's a product of perfect squares, because it does look, x to the 4th. And let's see if we can write this in a way that we would recognize how to factor it a little bit better. So let's factor out a 1/4 x to the negative 4th power. So this is going to be equal to 1/4 x to the negative 4 times, so let's see, I factored that out. So if you factor 1/4 x to the negative 4th out of this first term, and I could color code them a little bit, this first term, when you factor this out, is going to be x to the 8th power. Now this term right over here, if I factored out a 1/4, it's going to be equal to 2x to the 4th. So this term right over here, once again, this is the powering through the algebra part. So plus 2x to the 4th. And then this one is pretty straightforward. This is just going to be equal to 1. So plus 1 plus 1. And now this is looking interesting, because this one, well, this right over here, we could rewrite as 1/2 x to the negative 2 squared. This is equal to, that same color, 1/2 x to the negative 2 squared. And then this over here, we could rewrite this as x to the 4th plus, actually, let me write it this way. This is going to be x to the 4th plus 1 squared, right? X to the 4th times x to the 4th is x to the 8th. 1 squared is 1. The product of them times 2 is 2x to the 4th. So this over here is the same thing as that. And so now if we wanted to take the square root of both sides, so if we wanted to say the square root of 1 plus f prime of x squared, notice I'm just focusing on the algebra. So what we've done so far, this is 1 plus f prime of x squared. Now we want to take the square root of that. So that's going to be the square root of this. And so that's going to be equal to, Square root of this is, let me just color code it. This is going to be 1/2 x to the negative 2 power times x to the 4th plus 1 times x to the 4th plus 1. X to the 4th plus 1. I did that right? Yep. Or I could actually, now that I did all of this to put this in a form that I could actually recognize, now I can distribute things back. This is going to be equal to 1/2 x to the negative 2 times x to the 4th is x squared. 1/2 x squared plus 1/2 x to the negative 2. And if we're going to take the, let me rewrite this. So that's 1 plus f prime of x squared. But now let's take the definite integral. So let me give myself some space to write my dx. So we're going to take the definite integral, in this case, from x equals 1 to x equals 2. So it's the definite integral from x equals 1 to x equals 2 of this dx. So it's going to be the definite integral of this from x equals 1 to x equals 2 dx. And so this is fairly straightforward. The antiderivative of 1/2 x squared, that's going to be what? That's going to be 1. See, it's x to the 3rd, and we divide by 3. So 1/2 divided by 3 is 1/6. 1/6 x to the 3rd. And then this is going to be, we're going to increment, this is going to be x to the negative 1. We're going to divide by that. So minus 1/2 x to the negative 1 power. Is that right? Did I do that? Yep, negative 1. When you take it, yep, negative 2. And then this one, yep, that looks good. And we're in the home stretch. We're going to evaluate it at 2 and at 1. And so we get, when you evaluate it at 2, you get 2 to the 3rd.